Hello and welcome to a Simutech tips and tricks video. In this tips and tricks video, I will show you how to recover results from a distributed ANSYS run where the solver may have crashed mid-run and you need to recover those files. So to begin with, I'll describe a little bit of what I did to set up this model. Just have a simple block model here with a fixed support at the bottom and a force applied at the top. So the model doesn't matter, yours might be much more complicated. However, what I did to simulate a crashing analysis is set it up such that it would solve 100 substeps. And then mid-run, I basically used the task manager to end the analysis, simulating a crashed ANSYS run. A couple other things about this analysis, I chose to keep all the restart files at every single load step or substep. And you'll be able to see that I can reuse these restart files once I combine the results file from the solve. So when you have a crashed run like this, and you go to the solver project directory, and I can do this by highlighting the solution branch, right-clicking, and then open solver files directory, you'll notice that there's nothing in there. This is because when ANSYS does a solve, it actually writes it to the project scratch directory. I can find this project scratch directory fairly easily, and the location of this is where you've saved your Workbench project. So in this Windows Explorer window, I'll just double click the double arrow button here and go back to the ANSYS combine, which is where I saved my project directory, or where I saved my Workbench project. So you'll see that there's the underscore project scratch directory. This is the folder location that we want in order to find our results file. I'll double click on that, and then I'll double click on the other folder inside of that. Here is all of my saved solver files. If I type in the search bar .rst, you notice that I have two files here. So unfortunately, Mechanical can't read these results files because they are a distributed result file. What I need to do is use APDL commands to combine these into one. So to do this, I'll exit out of my search. I'll go up to the Explorer window bar here, highlight that, right-click, and copy. And then I'll want to start an APDL interactive session. So I'll go down to my Windows search Windows bar, and I'll just type in Mechanical. And you'll notice that Mechanical APDL Product Launcher 18.1 will come up. So I'll go ahead and start that. So now what I want to do is paste in the path that I had from the project scratch directory into my working directory. So I just highlight that, delete what may have been in there before, and then select paste. Now I need to verify the high performance computing setup. To do this, I'll go over to the high performance computing setup, and then we need to actually start the product launcher or the APDL interface using the distributed computing option. So what you would want to do is click on the bullet used next to use distributed computing, then use local machine only. And since I only had 2 cores solving, I'll just specify the number of processors to be 2. But you may need to change this depending on how many processors you use for your distributed ANSYS run. So now I can go back to file management. I'll just specify a job name as file, and then hit run. So once I have the interactive APDL environment pulled up, I can then combine the results file. It just takes 2 commands to do so. And first, I'll type in /aux2, and then I'll type in combine, RST. Once I hit enter, It'll combine the results file. And I can verify this by going back to the project Scratch folder. And if you sort by date modified, the last updated file will be this file.rst. And it should be the sum of the size from both results file. And if I recall back, it was about 8 megabytes per result file. So you see that this file is 16.5 megabytes. So now what we need to do is copy all of these files to the solver directory, the permanent solver directory that we looked at where there was no files before. So what I can do is first I'll want to exit out of APDL and hit quit no save. So then I can select all these files by hitting Control A, and then I can right click and hit copy. And then I want to go back to the solver directory for mechanical. So I can go back to my mechanical window here, highlight the solution branch again, open solver files directory, and I'll right click in here and hit paste. So depending on the size of your results files and everything, it may take a little while to copy and paste this, but that's okay. So now that I have it in the solver directory, the permanent solver directory for ANSYS Mechanical, I can go back to the solution branch inside of Mechanical, go to Tools, and then Read Results Files. And I'll want to go to that path of where that solver directory is. So if I go to Desktop and go to the project folder, there's my Workbench project. I want to go into DRes combined _ files or whatever your project name is. Go to DP0. And since I only have one system, it'll be the SYS here, but you may have multiple systems, so you'll need to verify which actual analysis system that is. And then I'll go into mechanical, and then I'll need to find that results file. So since it's the most recent file copied, it should be at the top if I sort by date modified, pretty close there, and I'll read that results file. So again, you want to make sure that it's in the same units that you used to solve. I solved in inches. So I'll go ahead and hit OK. And now it's getting the results from that results file. And you'll notice that if I pull up my graph here, it's saved to 0.64 seconds, which is 64% of my run done. But you'll also notice that in my analysis settings, I can restart this analysis from midway through. So by using that combine command inside of APDL, I was able to recover my results file, and now I should be able to continue solving from here on out. And I can double check this and show you guys how that works. Just hit solve. And so it's restarting the analysis. And depending on how long your model takes, this one's fairly quick. I now have a fully solved model that's finished to the end of time step 1. So thank you for tuning in, and I hope to see you guys next time.